In this video, we are going to explore the process of accommodation, which is a reflex mechanism that automatically adjusts the refractive power of the eye's lens, allowing us to clearly see both nearby and distant objects. This dynamic process involves several key parts of the eye working in coordination. We will also briefly examine how corrective lenses, such as glasses, assist when this natural reflex is not functioning optimally. Looking at a cross-sectional diagram of the eye, the primary components involved in accommodation are the cornea and the lens, both of which bend or refract incoming light rays. Additionally, we must consider the roles of the ciliary muscles and the suspensory ligaments, which control the shape of the lens. When light from an object enters the eye, it needs to be focused precisely on a tiny region of the retina called the fovea, which is responsible for our sharpest vision. To achieve this, the light must be refracted or bent accurately. Most of the refraction occurs at the cornea, which always bends light to the same degree, regardless of the object's distance. The lens's job is to fine-tune this refraction so that light rays converge exactly on the fovea, whether the object is far away, in which case the light rays are nearly parallel when they reach the eye, or very close, where they enter at wide angles. When we look at something close to us, the light rays need to be refracted more sharply. Although the cornea already refracts the light, it is not sufficient on its own, and the lens must provide additional refraction. To do this effectively, the lens becomes short and thick, increasing its curvature and therefore its refractive power. From the front and side views of the eye, we can identify the lens in the center, with the suspensory ligaments attached to its edges, which in turn connect to the ciliary muscle that encircles the lens like a ring. Note that these are not the same muscles as the ones in the iris that control pupil size. When viewing a nearby object, the ciliary muscle contracts inward toward the lens, which causes the suspensory ligaments to slacken and become loose. As a result, the lens, no longer held tightly, springs back into its natural fatter shape, enabling it to bend light more strongly and direct it onto the fovea for clear vision. On the other hand, when viewing a distant object, the required refraction is much less, since the cornea already does most of the bending. In this situation, the lens needs to be flatter and less curved. This is achieved by the ciliary muscle relaxing and moving outward away from the lens, which pulls the suspensory ligaments tight. This tension flattens the lens, reducing its refractive power. By comparing these two conditions, we see how the lens shape changes, rounder for near objects and flatter for distant ones. It is important to remember that ciliary muscles are true muscles, so they can contract and relax, whereas suspensory ligaments cannot actively contract. They simply respond to the tension or relaxation of the ciliary muscles, becoming either taut or slack. Now, let us consider what happens when accommodation does not function correctly. If the lens cannot refract light strongly enough, this results in long-sightedness, also called hyperopia. People with this condition can see distant objects clearly, but struggle to focus on nearby items. In a hyperopic eye, light from a near object is not bent enough, so the rays do not converge before hitting the retina, causing the image to appear blurry. It is as though the image forms behind the retina. To correct this, glasses with convex lenses are used. These lenses add additional refraction before the light enters the eye, allowing the natural lens to complete the process and focus the image directly on the retina. On the other hand, when the lens bends the light too much, it leads to short-sightedness, also known as myopia. People with myopia can see objects up close clearly, but have difficulty focusing on distant objects. In a myopic eye, light from faraway sources, which normally needs minimal refraction, is overbent, causing the image to form in front of the retina. This also results in a blurred picture. To fix this, glasses with concave lenses are prescribed. These lenses spread the light rays out slightly before they reach the eye, counteracting the excessive bending by the natural lens and helping the image to focus precisely on the retina. The medical term for long-sightedness is hyperopia, and for short-sightedness, it is myopia. Understanding these concepts helps explain how the eye naturally adapts to visual demands and how optical aids like glasses support those whose accommodation mechanisms are not working correctly. That concludes everything for this detailed explanation of accommodation and the correction of common vision defects.